Welcome to the second tutorial on processing. In this tutorial, we learned two main things. The first one, data types and variables. And the second one, how to create dynamic animations. The first topic, about data types and variables, is motivated by the necessity or requirement to store data that has to be used at a subsequent stage during the program's execution. Now you can have several types of data. For example, if you have a moving ball, you may have its x and y coordinate, its speed in both directions, and so on. If you're running an inventory application, you may have unit price. If you're running a student application, you'll have something like a GPA. The common thing between all of them is that they're all real numbers. In processing, we call these a float, and a float is 4 bytes long. We can declare a floating point variable using a variable declaration where we have a float and name of the variable, which is GPA. We can display this value using println, but in this case it will give us an error that the variable may not have been initialized. So we initialize it to, let's say, 3.2, and it displays the value 3.2 over here. The second category of variables is integers. For example, quantity, number of students, age, population, year, month, and day. They're all integer values or whole numbers. The size of integers is also 4 bytes. So I can declare an integer like this, that int number of mangoes is 12, and display the number of mangoes. So I get 12. If I try to say number of mangoes is 12.5, it doesn't work because you're trying to copy a real number into an integer, which is going to lose precision, and that's why it's not allowed. Please note, you can do the other way around, where you copy an integer into a float. Next is something like gender, which is a single character text. This is called a character in processing and is 2 bytes long. Character ch is characters are always specified within single quotes, and the value of a character can be any single character, like a star, let's say. We get a star over here. Please note that characters have corresponding integer values. So I can say character ch is 65. The value of character capital A is 65. So what we get as an output is capital A. Similarly, if we type 90, we'll get a capital Z. If we type 97, we get small a. Then 98 is small b, 99 is small c, and so on and so forth till 122, which is small z. So we leave it at 65, which is capital A. The next type of variable is a yes or no type of variable, which is called true or false. The type of the variable is Boolean, and the requirement is to check if the game is paused or not, if the door is open or not, if the TV is on or off, and if the level has been activated or not. These are all Boolean types which have just two options: true, which means yes, and false, which means no. So we get true. The only other option is false. The last data type is text values like names, email addresses, postal addresses, etc. This is a special type of data type, and you can see that it's different from the others in that the S is capitalized. The name is John Smith. All strings are defined between double quotes, not single quotes but double quotes, and can have 0 or more characters inside them. So name is John Smith. That's all we need to know about data types and variables for the time being. So now we can start with drawing some basic dynamic animations. In terms of animations, the main thing that you need to understand is the existence of two methods, which is setup and draw. Void setup, open and close round brackets, open curly brackets, then you can write all the statements here and close the curly brackets. Similarly for draw, void draw, open and close round brackets, open curly brackets, and write your code here. In processing, whatever code you write in setup is executed at exactly once at the beginning of the program. So when you run your program, this code will be executed exactly once, and then it will go to draw. Whatever code you write in draw executes repeatedly. So draw executes like background 255, ellipse mouse x, mouse y 50, 50. Mouse x and mouse y record the current location of the mouse, which is quite useful. So mouse x records the horizontal distance of the mouse from the origin, while mouse y records the vertical distance of the mouse from the origin. So it erases the background, draws the ellipse at the current location of the mouse, then erases the background again, draws the ellipse again, erases the background again, draws the ellipse again, and so on and so forth. So it's a continuous cycle. So my program just keeps drawing an ellipse centered at the location of the mouse. In order to draw a simple animation, what we require is to draw the ellipse, let's say, at a specific location. So what we do is we'll initialize the diameter of our ball to be 50 and specify the initial x location to be negative diameter by 2, thereby placing it to the left of the screen, and draw the ellipse at x, height divided by 2. What happens to this is the point x, height by 2 is over here, and it draws an ellipse right here. You can see a little bit of an ellipse peeking outside the invisible area over here. Now, if we'd like the ball to move forward, we want its x location, or the horizontal distance from the origin, to increase towards the right. So we say x becomes x plus 1. So x keeps on increasing by 1. And you get that out. You can also increase x by a larger value, and the ball will go a bit faster. You can increase x by a smaller value like 0.2 because we declared it as a float, and it travels really slowly because it becomes minus 25, minus 24.8, minus 24.6, and so on and so forth. So when I say int x is minus diameter by 2, and let's say diameter is also initialized to be integer, it complains that you cannot convert from float to integer because If we do that, we are going to be losing precision. I, I highly recommend you using floats instead of integers wherever possible. So whenever you know that the value may contain a decimal component, you should always try to use a float. Let's set the speed to 1.5. I think that's good enough. We can also have a second ball that comes up from the top. So y is minus diameter by 2. We have another ellipse, but this time at width by 2, comma y, and y increases by 1.5. So we'll have two balls, one of them coming from the left, the other one coming from the right. Since the display window is of different size in terms of width and height, they don't cross in the middle. We'll write another example where we'd like a ball to travel from the top left corner to the bottom right corner diagonally. We already have our variables x and y initialized to minus diameter by 2, so we create an ellipse at x comma y having diameter, and both x and y increase by 1. In this case, because the ball is moving with the same speed in horizontal and vertical directions, it finishes up at 300, 300. What we want is the ball to travel from somewhere over here to somewhere over here. So we need to know the total horizontal distance traveled and the total vertical distance traveled. The horizontal distance traveled is diameter by 2 plus width plus diameter by 2, which is width plus diameter. Similarly, the vertical distance traveled is diameter by 2 plus height plus diameter by 2. Now the time it takes to cross the x-axis is the total distance, which is width plus diameter, divided by speed of x. And the time it takes to cross the vertical axis or the y-axis is height plus diameter divided by speed of y. Please note that these two times should be equal if it has to cross the complete window at the same time, which means width plus diameter divided by speed of x is height plus diameter divided by speed of y. If we fix one of the speeds to be 1, then speed of y becomes that, and that's the formula we use. So we'll fix speed x to be 1 and speed y becomes that. The only problem is that height and width have not yet been defined. Height and width are defined by the size method. Anyways, let's try to do this and you'll see that it will not work because the ball still crosses at that point. And that's exactly the reason why this happens, because height and width have not yet been initialized, so they are zeros right now. Hence, speed y becomes 0 plus diameter divided by 0 plus diameter, which is 1. What we need to do is to postpone initialization of speed y to after the size declaration. And now you can see that the program works correctly and the ball actually goes diagonally across. We can also create a second ball coming from the other side. Because these two balls are symmetric in nature, which means when the first ball is at location minus diameter by 2, the second ball is at location width minus diameter by 2, which is width plus diameter by 2. These two balls will crisscross. And we can have yet two other ellipses, which are at height minus y and height minus y. Now we have four balls coming from all four sides, going in opposite directions. So you can see that you can do a lot of cool stuff using draw and setup alone with some basic variables. Now we come to events, namely mouse and key events. There is a method called mouse pressed, which is void mouse pressed, open and close round brackets, open curly brackets, then the method body, and close of curly brackets. Whenever you press the mouse, draw finishes the current execution and then goes to mouse pressed, where it executes it once and goes back to draw again and repeats the execution of draw after that. So you can think of it as a special event which is executed once every time the mouse is pressed. So what we'll do is we'll comment our entire code. You know that slash star and star slash is a multi-line commit. And whenever the mouse is pressed, we'll fill with red. In fact, let's change the stroke to red. Draw a line at mouse x minus 20, mouse y to mouse x plus 20, mouse y, which is a horizontal line, and mouse x, mouse y minus 20, mouse x, mouse y plus 20, which is a vertical line. Also, we'll set, and we don't need to set the fill, we'll draw an ellipse at the location of mouse 30, 25, 25. Whenever I press the mouse, I get this target symbol because I had two lines and then I drew a circle with a white fill on top of it. The other methods that are there are mouse moved, which is called every time you move the mouse. So as long as you're moving the mouse, you'll get that. Please see, if I move the mouse really fast, these circles are far apart. If I move the mouse really slowly, they're closer apart. Because processing records the mouse location at a certain time interval. So in this case, what you can do is you can erase the background every time, so you see a much nicer output. So now what we have is a proper cursor. The next method is mouse dragged. You can easily guess that it's called every time you are dragging the mouse. You press and drag and it's called. If you just press, it's not called. If you start dragging it, it's called. So the idea is that the current mouse location should be different from the previous mouse location. You have mouse clicked, which is called every time you press and release the mouse at the same location. So if you press, move and release, it's not called. Even if you move slightly, so press, move very slightly and release, it's not called. The last one in the series of mouse events is mouse released, which is called every time you release the mouse. So you press, move somewhere, release. It's called press, release, press, release, press, release, and so on. The last of the events is key pressed, which is called every time you press any key. Please note this doesn't make a lot of sense because what you're doing is you're pressing the key. Whenever I press a key, it draws the target at the current mouse location. While usually what we do in such a scenario is I'm going to comment this out and fill with 0 and display the key code at the current location of the mouse. So text command is to display this value at this location and fill 0 because the default fill is white, so you won't see anything on a white background. So I can say G A U R A V. What's displayed are the key value, the codes of these keys. Instead of that, if you just say key and press G A U R A V, you get the correct value. So that's the difference between key and key code. That's not a bad screensaver. So you can do that. So you can do something like this basically: rand x and rand y, where rand x and rand y are random values. In processing, you can generate random values using the random keyword. If you say random width, it's a value all the way from 0 to just under the width. So if the width is 500, rand x can be any value from 0 to 499.999. Similarly, if the height is 300, then rand y in this case can be anything from 0 to 299.9999. This is pretty cool! And that's it. Of course, what you would like is for the values to be displayed in a line. So what we'll do is we'll have text x and text y. They are both 30 to begin with. So whenever a value is written, we display that text x and text y and increase text x by 20. This is really nice. Of course, the question is what happens when I go out of the screen, because it keeps displaying values on the same line beyond the screen. So I want to change the line. So what you can do is you can apply the mod operator mod width. So as soon as it goes beyond the width, it will go to 0 and go back again. So it's going to partially solve our problem, but not so well because it overwrites on the same line. The correct way to do that is using a condition, which we learn in the next tutorial. The last thing I would like to say is that all these variables that we declare at the top are global variables. These are variables that can be accessed by setup, draw, key pressed, mouse pressed, all the methods. But if you declare these methods inside a particular method, if you declare these variables inside a particular method, the other methods cannot use them. So key pressed cannot use text x and text y because these variables have been declared inside setup. So we'll declare them outside all the methods. One more thing, let's say I get rid of the void draw and run this. I press a couple of keys, nothing happens. This is because void draw is in charge of putting all the output on the screen. So if I don't have void draw, nothing goes on the screen. So I get something now, which is correct. So that's all for the second tutorial for processing. Hopefully you benefited from it, and I'll see you again for the third tutorial, which discusses expressions and conditions. Thank you.